So today's lesson is called the binomial expansion. So this gets a little bit heavy, and so if you don't know the foundation, it makes it harder. Okay? So let's start by learning what Pascal's triangle is. Okay, so here's a pattern of Pascal's triangle: 1, 1, 1, 1, 2, 1. I'm going to give you the next row: 1, 3, 3, 1. Do you see a pattern happening? Okay, so in the next row I'm going to put a 1 there. I'm going to put a 4 there. See what I'm doing? What should I put right here? Anybody figure it out yet? 6, 4, and a 1. You see it yet? What am I doing? What's the next row? Go ahead, see if you can get it. 1, 5, yeah. How is it going to continue? 10, 10, 5, and 1. Yep. Okay, so obviously the outsides are always 1 like that. And then it's an addition, 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 right? 1, 6, 15, 20, right? That's going to be the next one. Should we write it in? 1, 6, 15, 20, 15, 6, and 1. Do you also notice how it's symmetric like this? 1, 6, 15, 20, like from each direction. That goes the same as well. Okay, so we're going to figure out what does this connect to. Okay, so this is the binomial expansion. So what does binomial mean? It means 2 terms. And expansion is that I could put it to any exponent. Okay, so what is anything to the 0 power? 1. What is anything to the 1 power? Itself. Okay, you know what I'm going to do though? I'm going to put 1x and 1y. Okay, just so we can see something. Okay, x plus y squared. I'm going to do this for you. Ready? Okay, so if I square something, this is what it looks like repeated. Okay, let's FOIL this. Ready? What's first times first? X squared. This makes an xy on the outside, xy on the inside, and y squared last. This together makes 2xy. Okay, so there we go. There's our answer. I'm going to just add, for the sake of what this is, I'm going to add a 1 and a 1 in front of those things just so we can see stuff. So I FOILed it. I got 1x squared plus 2xy plus 1y squared. Is anybody finding a connection with this triangle? Just a 1. Then we had a 1x, 1y. Then we had 1x squared, 2xy, and a 1y squared. Look at that. Okay, so I don't really want to cube this by hand. I'm sure you guys would love to do that, right? Cubing something. Do you want to do all that long way foiling, or should we just understand the shortcut? Okay, so the shortcut is going to have 4 terms to it. So it's going to have 1 something, 3 something, 3 something, and 1 something. Okay, looking here, look at what's happening. There's no x's at all. There's an x squared. What do you think this is going to start with? X cubed. Okay, so then here's what's going to happen. This has an x cubed in it, and then you're just going to go downhill. X cubed, this is going to have an x squared, this is going to have an x, and this is going to have no x's at all. Cubed, squared, x, no x's. Okay, look at here. What do you think I'm going to end with? This had no y's, a y squared. This would end with a y cubed. And then what do you think is going to happen going in a pattern of y's? This is going to end with a y cubed, so this is going to have a y squared, a y, and no y's. So basically, I started at the most x's and I went down. I started with the least y's and I went up. Okay? Also, here's a little side note. The exponent 3. Together, no matter what, they're going to have an exponent 3. There's only an exponent 3 there. Here there's an exponent 2 and 1, which makes a total exponent 3, total exponent 3, total exponent 3 every time. Okay, the next one. So here we go. What's the next coefficients? 1, 4, 6, 4, 1. Okay, so I'm going to start this line with an exponent 4, so x to the 4th. And then I'm going to go down, 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 down. X cubed, x squared, x, no x's at all. Then I'm going to go starting with no y's, a y squared, a y cubed, and a y4. Okay, how does this differ from this example? So they're almost the same. They both have the 4th degree. The only difference is this negative. So what is that going to do? It's going to make every other term negative. So it's going to look almost the same. So x4, but then minus, then plus, then minus, then plus. So that's the difference in that one. A negative symbol. Okay, you're probably wondering, why are we learning this in this unit? All these numbers connect to your choose button, your combination button. All of these numbers connect to that choose button. Okay, so here we go. When we see this 1, it's because we have something to the 0. When we see this, it's because we have something to the 1. When we see this, okay, and so on and so on. This is where these were getting connected to. Okay, so on this one, I have the exponent 0. And I'm going to choose 0, which is 1. On this one, it's an exponent 1, so I'm going to start with 1, choose 0, and 1, choose 1. On this one, it's an exponent 2, so I'm going to start it with a 2, choose 0, which is 1. A 2, choose 1, which is 2. And then a 2, choose 2. So let's check out the next one, an exponent 3. So these numbers, there's 4 numbers. They should come from 3, choose 0, 3, choose 1, 3, choose 2, and 3, choose 3. Those 4 numbers should be the pattern. So I'm going to try it on my calculator. So 3, choose 0 is 1. 3, choose 1 is 3. 3, choose 2 is 3. 3, choose 3 is 1. Those numbers, that's where it's coming from. So you can keep going in the pattern to see if it works. So if I take this one, for example, randomly, this would be 6, choose. 0, 1, 2, 3. 6, choose 3. 6, choose 3 should be 20. There it is. Okay, so here's a couple things to note. Did you notice that if the exponent was 3, I had how many terms? I actually end up with 4 terms. If the exponent is 3, I end up getting 4 terms. So what's going on? Why is that counting like that? Because what did I start counting from? 0. So everything else basically you've ever done in math, you always start counting at 1, right? So because I'm starting my counting at 0, it's adding on an extra number. So if I count from 0, 1, 2, 3, that's going to make 4 terms. Okay. Now we're going to extend this. Okay, so here is this crazy looking formula. Looks complicated, but it's not, so we're going to break it down. Okay, so here is what I did in a simple way for this. Okay, so first of all, if I take back to this example, the exponent was 4. So here's what I did. I did a 4, choose 0. I took the first item, I took the second item. So the first item was x, the second item was negative y. I gave this one the exponent 0 to match that. And I gave this one the exponent of the subtraction. So that's what this formula is doing. So the exponent here matches your choose number, and then that's the subtraction one. So this was 1, x4. That's it. That's how I got there. Okay, so this one, how am I going to get that? I'm going to go 4, choose 1. Because I'm going to go up 1, 4, choose 0, 4, choose 1. The first item, the second item. So there's an x first, a negative y second. I'm going to match 1 there, because whatever this is that. And then what's the subtraction exponent? The exponents always have to add up to 4. Exponents always have to add to 4. Look, that's how I got. So this is why this was negative. Because look, I had a negative y, so that's why that term was negative. Okay, what if I show you one more? So what would you have done to do this if you're following the pattern? You would have gone a 4, choose 2. That's how you get to the 6. The first item, x. The second item was negative y. This choose number has to match the exponent there. And then this exponent is the subtraction, so they have to add up to 4. This is why I got a positive on that, because what is negative y squared? Positive. So this is why I'm alternating positives and negatives, because here this negative y business was to a 0, so that's positive. Now it's negative, now it's positive. On the next one it would get cubed, which will turn it back to negative. Okay, here we go. We're going to add a little more complexity into it because now I added some more numbers in here. So there's a 4 on something. Okay, so it's going to change a bunch of stuff. Okay, so here's my pattern. So you can see 4 choose 0, 4 choose 1, 4 choose 2. So this one would be a 4 choose 3, and to end it would be a 4 choose 4. I always write both items. So there's an x squared item and a 4y cubed item. Those are the two items. Okay, do you see whatever your choose number is? So I'm going to say this is my choose number. 4 choose what? Has to be the exponent on the end. Do you see that? Do you see that? So then this one is a 3. This one is a 4 at the end. Okay, if I put a 3 there, I need to put a 1 there, because the total exponent is 4. The total exponent is 4. So I call it my subtraction. And if this is a 4, then this is a 0. Okay, so you would have to be able to calculate this. So first of all, what is 4 choose 3? So that's 4. X squared, just to a first degree, is just x squared. Okay, you're going to have to cube this. So don't forget there's a coefficient 4. So what is 4 times 4 times 4? You have to cube that. That's 64. And then y to the what? What do you do with exponent to an exponent? We just did this log rule stuff. 9, right? So there's our final term, because I'm going to times that 4 and that 64 together. That's what I did there. That's it. Okay, last of this one. So first of all, 4 choose 4 is the value 1. Anything to the 0 has a value of 1. Okay, we're going to 4th degree this, so I have to do a 4 to the 4. So 256. Y cubed to a 4 will make a y to a 12th. Okay, we're going to do flipping the next page. I just realized the instructions for the question are here. Find the 4th term. That's supposed to be on the other page. So there's the question. It was supposed to have been transferred over. Find the 4th term. Okay, here we go. So this is really tricky, but 6 is my exponent. So if I start counting, 6 choose 0 is how I start. 6 choose 1, 6 choose 2, 6 choose 3 is my 4th term. Okay, so your choose number is always one lower than the term you're on. Why? Because this 0 counting business throws us off by 1. Okay, it's always because we started at 0. So this is the 1st term, right? The 2nd term, 3rd term, 4th term. So you can always see this number is 1 lower than where we are. Okay. A, write the first item, x cubed. B is the second item, 4y squared. Okay, look at the formula. Whatever you choose number has to match that exponent. So this choose number has to match that exponent number. So if this is a 3, then this is an exponent 3. And then the subtraction exponent. So my total exponents have to make 6. So then this would also be a 3. So that I have a total exponent of 6. Okay, that's it. Go ahead. Now the rest is calculations. So that's 20. That's an x to the 9th. This, you're going to have to do a 4 cubed in the front of that. So I should get 64y to the 6th. Okay, so now simplifying the 20 times 64, and then that's it. I can't do much else. Okay, next one, same thing. Okay, so here we go. The exponent is 10. So I'm going to go 10, choose. And I'm trying to get to the 7th term. So what is my choose number? If I get all the way to 7, my choose number is 6. Because the first term had 0. The second term had a 1. Third, right? You see what I'm doing? Okay, so that's what I did. The 7th term is actually choose 6. Okay, the first item is a 3x squared, and the second item is a negative 4x. Okay, now the sixth choose number will be the exponent on the outside, like that. And the other exponent would be should you pick a 4 so that we can make 10 total? Okay, and then it's calculation stuff. Okay, so calculator, that makes 210. All right, here you're going to have to do 3 to a 4th degree, which in my mental math, that should make an 81. X squared to a 4 would total x 8. Okay, be careful here. What's this, positive or negative? This thing right here. When you do that, it should be positive, right? Because a negative to a 6, that should be positive. Oh, are you getting a massive number? Coefficient, big? What's the rule here with this x business when you put those x's together? Remember that rule? You're going to add them, right? Add the exponent numbers. Okay, 2 more questions here. Okay, find the 5th term. So what choose what? You have an exponent number and you're trying to find the 5th term. So give me that choose pattern. So the exponent is 7. And if I'm going to get to the 5th term, 0, 1, 2, 3, 4. Right? Okay, so the first item is a 2x squared. And I'm going to rewrite this item. I'm going to rewrite it like that. Is that the same thing? You remember that rule? If it's a negative exponent, it can move to the bottom, right? Remember, we talked about that in logs. Okay, that has to match, right? So this is my choose number. And then that exponent is a subtraction. So total 7 up tops. Okay, so that's the hard part. And finish it off on your own. Okay, and then I don't think it would matter how you write your final answer. I gave you kind of two options here about that x. Okay, which term contains an x to the 12th in it? Okay, so on this one, we're going to forget all the number stuff, and we're going to only deal with the variable. Okay, so I only want to deal with the variable, just the x stuff. So forget the choose numbers, all that. Forget the coefficients, nothing like that. Okay, so I'm going to kind of just chunk the formula. I'm only going to take just the x's from the first item and just the x's from the second item. Okay, so that's kind of part of the formula, but only a little bit of that formula. And eventually I want to get an x to the 12th. That's my goal. Okay, what do we always put on the outside? On the last thing is always our k number, right? Our choose number. And what do we always put here? We always need the subtraction there. Okay, so in this case, I need to go 8 minus k, because those have to add to 8. That's the subtraction exponent. Okay, this is the choose number, and this is the subtraction of the exponents. Okay, so here we go. We have to multiply that. So x to the 40 minus 5k. Times an x to the negative 2k. Okay, what do you do when you have a multiplication? Now you have to add the exponents. So exponent to an exponent you multiply, and then in this, right, you add the exponents. Okay, is this safe to say in math that we can forget about the x's? Can you see that? Because if both have a base x, we just have to now equate the exponents. So forget the x's. We're going to say, well, this exponent should equal that exponent, so that the sides can be equal. Okay, I got a value of 4, but this isn't my answer. My question is all about what term am I on? So if I'm going to choose number 4, what term position am I in? Because your answer is not 4. It's not the 4th term. If your choose number is 4, what term are we actually on? We're on the 5th term, right? That's 0 counting. So if we have all the way to a choose 4, that means we're on the 5th term.